Hello everybody, day 18, part 1. Let's cover what we have in here. We are starting with boiling boulders. Well, you have a whole story, as always, which covers the lava and the air droplets, or rather water droplets. But all in all, you can think of it as a 3D space kind of issue. So you have cubes, which are represented by this sort of input. Those are the coordinates of the cube. Each cube is a 1 by 1 by 1. Whenever the cubes touch each other, they block one of the sides, actually from both of those. So when we calculate the surface area, we are calculating the sides that are exposed to the world. So for this example and those cubes, we have 64 sides exposed and visible. I discovered a nice way of navigating files, so take a look at that. We can go through the files in this sort of breadcrumbs kind of thing. We can navigate through here. Let's start with input module. As easy as it can be, so we have the coordinates and we're reading the input, which is just from the string split by the lines and line split by the comma, and then for each just parse it as integer, and that's it. That's the whole spiel. You just return the vector of those coordinates. We're looking at each of the cubes and then we calculate how many neighbors that cube has. To get that, we need to target a specific coordinate, or rather a specific cube. Then we also need the whole input or all other cubes. What we do is we build the potential neighbors, which is 6 cubes, all of them moved by one space in either X, Y or Z axis. Once we build that short vector, we iterate through it and then we just check whether that particular neighbor is available in the input. The last step to get number of exposed sides is really to glue it together. So we read the input, which is vector of coordinates, and each coordinate represents a cube. So we iterate through the input, then we map each coordinate with how many neighbors it has, and then we calculate the number of sides visible, which is actually 6 minus number of neighbors. Actually, let's run it first. So this is the outcome of my input. I wanted to note two main things. First one is about the efficiency of the algorithm. This is not a perfectly efficient algorithm because we are calculating for each of the cubes, we are calculating the number of neighbors. What we could strive to do is really join those calculations. If we have 2 cubes touching each other, A and B, if we calculate for A and we realize B is one of the neighbors of that cube, then we could subtract right away from B also. So we would understand in the future that B already has one side less exposed. This would be more efficient. Then again, it's not always about efficiency, it's also about readability. This solution, even though it's not perfectly efficient, is very readable and very easy to grasp. The second part is, I've been testing GitHub Copilot for some time now, and here is something that blew my mind in a bit of a negative way. When I started this solution, what I started to write was really struct chord, right? And as you can see, even now, GitHub right away understands that I need coordinates and that I need X, Y, and Z axis. And this is weird because, at least in my opinion, I usually would assume when we are talking about coordinates, we are actually talking about two-dimensional things. rather than three-dimensional things. It seems to me that perhaps GitHub Copilot is actually trying to figure out, based on the name of my project, Day 18, that it's actually correlated to, well, day 18 of Advent of Code, right? Another interesting part was when I started to write the first test. So I didn't have to write those coordinates by hand, those coordinates that you can see in here, which I separated later on. I didn't write that. It was actually written by Copilot. This is something that I really didn't want to do myself, so this was very useful. So I'm not used yet to the Copilot, and it's still a bit strange to me how it can be helpful, but I also don't trust it yet. Oh, one more thing. The Copilot actually wrote this implementation. Yeah, granted, it's super basic and super simple, and like everybody could write that. It actually was not written by me. So once again, kinda weird. However, when I was struggling with Day 17 Part 2, Copilot really wasn't helpful at all. It was proposing weird things that didn't match my solution. I couldn't trust it then, or maybe I didn't want to trust it then. The situation was different when I wanted something very specific. I wrote something for myself, like a comment that I'm gonna, for example, copy the map to include it in the snapshot or something like that, right? So when I wrote this sort of comment, it realized immediately what I meant, and I could just use the code that it proposed. It can be helpful. It's sort of now learning also to leverage that help. Alright, let's end it in here today. Thank you very much for listening and for paying attention, and as always, we can do better as a pack. Bye.